So I'll go back a bit, and so just to recap there, this one here is nutty important, crazy important. Sorry about that. Just can't get anything going. It is what it is. There we go. Turn off the bloody phone. Now, this one here, okay, like you find your z-score, you're going to find your probability underneath the curve using this. And I'll show you guys how to do that there meticulously. It's not too bad. But it doesn't, and everything you do here will just go right to mashed potatoes if you don't get this one. Now, I'm going to go into this. I will refer to this slide for the rest of the slide, or for the rest of the PowerPoint, okay? This table here, okay, you'll notice that there are no numbers bigger than 0.49999. And I think it's right down here, 4997, okay? There are no numbers bigger than 0.5, 50%, because this table here only measures from here and out, which is maximum 50%. This table also measures this side, which is also maximum 50%. So utilizing this table here is via this way only. And we'll show you this, okay? 50%, 50%. So let's have a look here. How do we do this? Once this clicks, it's not too bad. So on a test, this is what I'd give you. Find the area to the left, find the probability to the left of z is equal to plus 1.99. So plus 1.99 is right here. Does this have to be exact? Like, you'll see there that I've given you these style of questions there later on in the PowerPoint without a diagram, because you don't even need a diagram to do these, but a diagram does help. Now, you'll notice there that we don't have our standard deviation 1, our standard deviation 2, 95%, standard deviation 3, because those are just numbers. They're not barriers, they're just numbers, because here at this point we have standard deviation 1.99. Okay, now it doesn't fall under our easy peasy first, second, third standard deviation, which is the whole point of a z-score. So what we need to understand here, though, find the area to the left of z is equal to 1 plus. So you're looking at all of this information. So what's the probability of choosing an apple from this bunch right here? Well, what we've got now is guess. What do you think it would be? Because this side here, we already know the answer. You're not going to find it on the table. This side here, because we're measuring this side and this side together to get one number, this side right here is 0.5. So right there at the side of your page, you can write 0.5000, however many you want. Okay, so that's 50%. Half the question's already done. And now we just need to find the area under the curve for this section. Well, I don't really know it. So what we do is, I've given you the z value here. So you don't need to plug in a z value to find, you don't need to find the z value. I've given it to you here. So z deviations 1.99. So what do we do here? I'm just going to blow this up. So what you do is 1.99, right? You go down 1. Okay, so there's 1.9. All right, and sorry, it is actually the number there. And so what we get here is a value of 0.4767. 0.4767. What this means is, there's your 50%, okay, because measuring from there to there. And we found that the area under the curve for this section, because that's all it's measuring is from here and out, at this standard deviation of 1.99, I got a number of 0.4767. So what does that mean? This is 50%. This right here is 47.67%. So if I want to find the area under the curve for all of these guys, easy peasy, I just add them up. Okay, so the probability of choosing an apple from this group here is 97.67%. And how we like this is we like it in decimal form. That's why on the assignment there, that's out right now, you'll see there that with the multiple choice answers, which we will go over, okay, after we do the PowerPoint, okay, you'll see there that the multiple choice answers are all in this, okay. I'm just going to stop sharing and to see, are you guys okay? You guys can hear me all right? Everything's all right? Is there I hope you guys are doing okay, and we're going to continue on with this, all right? So I just wanted to check the comments there. Good, good, good. So that's how we do this. I could give you the Z value, you tell me the probability. Okay, let's try another one. So find the area to the right of Z is equal to negative 1.16. So basically what we're looking for is all of this data. Okay, everything to the right. And I wouldn't give you this, I wouldn't give you this, I don't give you the arrows, you know what I mean? And even some cases there, I wouldn't even give you the graph. So this is all you would get. So we want to find the area to the right of Z is equal to negative 1.16. Again, because how this table works, we break it up into two. So I got a full side on this side, so right then and there, bang, 50%. Okay? And you see here that this one, we've got to measure this area in here. So on your table, I know this is negative, but we're dealing with absolute value. We're looking, like this is on the negative half of the graph, but we're looking for the area under the curve. So it'll always be positive. So you take your negative 1.16 and you just go positive. So you got 1.1, and then you'll see 0, 1, 2, 3, 4, 5. So right here, this is negative 1, or the positive 1.16. So we got a value of 0.377. And there you go. And because we're looking for this total area here, 87.7%, 0.877. That's how this one goes. So let me know what's going on, okay? And let me know if you have any questions on this. Let's try another one. Look at this one here. Find the probability, same as what we saw there last week, of choosing an apple between 0 and 2.32. Well, draw it out. Okay, so here you have your curve, and there's your 0, which is your mean. And we want to know the area under the curve. We want to know the probability between here and the 2.32 standard deviations. Okay, so what do? This thing measures from here out. So you just go to find 2.32. You just go down 2.3, 2.30, 2.31, 2.32, which is 0.48. Okay. And there we go. And you see, we didn't have to add 50%. We didn't have to add 0.5 because we're not interested in this area. We're only interested in the area that I'm asking for. Okay. Let's try this one. Now, is this one any more difficult? No. Find the area, find the probability between Z is equal to 1.68 and Z is equal to negative 1.31. So, if I don't give you the curve, you can draw this easy enough. There's your curve, there's your mean of 0. So positive 1.68 has got to be up here. So It's 1.68 standard deviations away, so it's somewhere in there. It doesn't have to be exact. It's just a representation to facilitate you in getting the right answer. And we want the area here negative 1.37, so that'll be on the negative side there, and there's that. So we want to know the probability of choosing an apple between this area. All right. Now, because of this slide right there, all right, that's how things are measured. Okay. Where was it? Right here. All right. So what we'll do is, and it doesn't matter which way you do it, you could do this one first or this one or whatever, but you're going to have to check your chart twice. So let's go to negative 1.37. Okay. Negative 1.3. Sorry, I know the arrow starts on 1.4, but it was just the way it goes. And you see 1.37 is 0.4147. So 41.47%. And then if we do the 1.68, 1.68 is 0.4535, I think, if my eyes are not deceiving me. And so here on this side here, there's a 45% chance. On this side here, there's a 41% chance. Add them up. Next question. That's how we do these. Okay? And you see in this case here, I gave you the Z's. All right? So these ones here, you're just finding the probability using the tables here. And you see these ones here, I gave you these just to show you that you don't need the diagram. Once you get good at these, you just be able to bang these out in a minute or two. And you don't need the curve to do these. Do I recommend drawing the curve? Absolutely. Just in the corner, scratch a piece of paper, just draw it. There's your mean there. You know where your first and second and third standard deviation should be. So, and you'll see here the probability of choosing an apple between 0 and 2.61. Okay, so go to our chart. So it'll be 0 to positive 2. Where am I looking at? Right, 2.16. So you just go down here to 2.1. That's 0, 1, 2, 3, 4, 5, 6. 0.4846 just to make sure. Yes, it is 0.4846. So that is your probability right there. Hopefully we see the same number on the slide. 48.46. 48.46. And you'll see here I've got the probability of choosing an apple between negative 1.87 and 0. So everything there is kind of below the 0 line. Is it any different? No. This is negative 1.87. Okay. What do we got here? You just go 1.87. I think that's here. I missed that comment. I'll read it. I hope everything's good. If it's not, let me know. I'll get to the comment. 1.87. Where the heck is 1.8? There's 7 right there. 1.8. So hopefully there. 0.4693. What do we got here now? 0.4693. Okay. Try these out. These are good. You know what I mean? Try them all. There's only a couple there. As far as questions go, I put questions there in the folder. As far as the book goes, there are some questions in the book that y'all can have a look at, but stick to the questions there that I've given you. Stick to the questions there within the PowerPoint. Master these. Y'all will be fine there for quiz 3 and test 3. And your assignment as well. Okay, so try these out. Any issues, let me know. What if I didn't give you a Z value? What if I just gave you the area under the curve? So here, I want you to find the Z score. I want you to find the deviation. And I've given you the area under the curve instead. So we're just working backwards, and you can see by the arrows here, we're starting here and working backwards. That's all it is. So find the value such that the area under the standard normal curve is 0.2123, so a probability of 21.23%. So you find the number there that's closest to 2123, and I've kind of done that, and lo and behold, it does exist, 0.2123. So what Z value is that? Okay, I've got 0.56, so 0.56, and you will see there that, there we go. That corresponds to 0.56 standard deviations away from the mean, right? Because that's what this thing is measuring from there to there. Okay, so in this case here, if I give you the area or the probability, you can backtrack and find the Z value that corresponds to it just by working backwards there. Okay, and you just find the closest number there. There you go. Here are some more that I've given you here. So here I've given you the area, the probability, and asking you to find the Z score. So you're just working backwards, you're just backtracking, which is exactly the same as this slide here. So hopefully there, that shouldn't be too bad. Okay, let me know if there's any issues. We're getting down to the nitty-gritty now, and these are some questions there. And as with these statistics questions, they can be kind of wordy and they can be kind of ugly, not nice to read. Okay, it's just one of the things there you're going to have to overcome. Ask a question, even on a testing situation. Ask me a question. Okay, I may get back to you in an hour. I may be away from the computer, but let me know. As far as I know, your test, the quiz will be open for a week starting next week, and your test will be, there will be time. I think the last test there was, I think I gave you a day and a half. I don't think it'll be that much time, but there should be an ample amount of time. I'm going to try and get it on the, we'll see. I want to see how things go with the assignment, and we'll work it all from there, okay? If I have to go back to a paper-based, I will. But we'll see how the assignment 2 goes, being uploaded there and answered through the e-portal, which is open now. Some people have already uploaded their answers, are already done with assignment 2. So let's have a read here. A survey by the National Retail Federation found that women spend on average $146.21 during the holidays. I don't know, man. What is this, 1955? Yeah. Assume the standard deviation, I spend more on that. I don't know what year this was from, but that's an interesting one. Assume the standard deviation is $29.44. Okay? Find the percentage of women who spend less than $160. So, I've given you all the information here. So there's your mean, average. So the average spending is $146.21. The standard deviation is $29.44. And I want to know the percentage of women who spend less than $160. So, how do we start this? I draw the normal distribution. So you see, I just draw these, and is it accurate? To some extent, but it doesn't have to be, because this is where I want you to be able to kind of guess. So here's your mean, $146. These are real values. This is not standardized yet. So there's my mean, is $146.21. And you'll see there that my standard deviation moves along. Here we go. And so the value that I'm looking for is $160. And I want to know the percentage of women who spend less than $160. So that means that it's all of this. Okay? And you could try and guess. So what percentage do you think this is? This is where I want you to this is so important because your answer coming from your calculator may not be, and I want you guys to be able to guesstimate your answer. So you look at this right here. What percentage? Well, we know that this is how much? 50%. So right then and there, it's 0.5 in there. And then we've got this amount in here. So what do we guess? 20, 30%, somewhere in there. It's somewhere in there. So we're looking for around 70%. Does it make sense? In and about, right? That's where we're at. So we're looking for an answer around 70%. Would you agree? I hope so. Okay. So now, what do we got to do? If I'm going to find the probability of this, I already know this probability, but this one here, I need to standardize it. So what do? We take this information right here and we use our z-score. Okay, so you use the z-score there. The 160, it's the value you're looking for, minus the mean. This is population mean. It's okay. So it's the value minus the mean, all divided by the standard deviation, which was all given to you. So you plug and play. You get $1.60 minus 146.21, all divided by the standard deviation, 29.44. You get this number, 0.47. Now, you go onto your chart here, and you go to 0.4. Sorry, it looks like it's coming from 0.5, but you know how formatting on Microsoft Word works. It's horrible. So 0.47 is 0.1808, so it's 18%. And remember this slide here. That's how this one works. So what does that 0.1808 mean? It's only talking about this distance in here. Okay? Because that's your 160 mark right there. So that is at 0.47 deviations. Okay? 0.468. Now, hold on here. Now, what we have now is, what we have here now, 47. So we got this 18% plus this one here. We add them all up and we get 68%. That's how this one works. We don't need to do anything to this side because we know that it's 50%. The only issue is trying to figure out this area right here. You use your Z value, you go to your table, find your percentage, add them up, and there you go, 68%. So let's try another one. All right. And you'll see here that the answer is acceptable because our guess was around 70%. If we had got an answer of 25%, we would know that there's something wrong because there's no way that this is 25% when this half right here is 50%. So make it make sense. Let's try another one. Newspaper recycling. Each month, an American household generates an average of 28 pounds of newspaper. So there's your average. Okay, there's your mean for recycling. Assume the standard deviation is 2 pounds. So if a household is selected at random, right, it's all this, right? Choosing a green marble. Find the probability of it generating between 27 and 31 pounds per month. Assume the variable is approximately normally distributed. Okay, this is a standard question. Standard. So to make it kind of go here, I draw it. Okay, there's my mean, 28. Okay, I'm looking for the probability between 27 and 31. And remember that slide there, that's how these things are measured using the z-table. So what are we looking at here? What do you think here? We've got, I don't know, 10, 15% in here. It looks like we've got all the information there for our 34%, maybe a bit more, maybe an extra 10. So somewhere around 50, 60%, somewhere in there. Okay. So I gave you two values right here. You will need to calculate two Z values because that's how this thing is measured. I need to figure out what this one is, and then I need to figure out what this one is, and then I just need to add them together. So these two values here I gave you, you'll need to do Z scores. And you see, you guys can put these in here, to kind of help you out. There's all the information there for your first standard deviation. Here's the next. And you know what I mean? You're kind of guessing because you're going to figure out exactly what's happening. All right? But somewhere in there. All right? So let's go. Here are the two Z values here. Okay, so we're looking at 27 minus 28, right? 27 minus 28, all divided by your standard deviation of 2. That's your formula, right? And that gives us a number of negative 0.5. So there's your real numbers, and here's your standardized number. So this is negative 0.5 standard deviations. It means it's below the mean. And then we do the same thing for 31, which was this other number, okay? You find your Z value here, and you get a number of 1.5. Okay, very good. So now you take your Z values, right? To right here and right here, they correspond to these numbers, so I don't, absolutely put one below the next. Sure, these are your real numbers. These are your standardized numbers. Okay, so, and you go digging, what was that, negative 0.5? So I got 0.5, because there's no negatives on here, we're just looking for the absolute value, so I got 19.15%. So 0.1915. That's the probability for this area, 19%. Now this area here, we got to find the Z. We found the Z score, 1.5. 1.50 is 0.4332, so 43%. So I add this one, we get a value of 62%. Was this close to our guess? Yeah, it was pretty close. That's what we're looking for there. Okay, so your final answer should be close to your guesstimate. That's your safeguard. Okay, and I want you guys to be able to guesstimate. It's a huge part of this section. Okay, deductive reasoning. What do you think it will be? Because you look at these calculations here. If somebody forgets there that these things are measured from the mean out, there's so many possibilities for error. So this is what we're looking for, okay? Have some fun with these. This one is a good one as well. Have a look. The American Automobile Association reports that the average time to respond to an emergency call is 25 minutes. So that's your mean. The average response time to an emergency call is 25 minutes. Assume the variable is approximately normally distributed. The standard deviation is 4.5 minutes. If 80 calls are randomly selected, approximate how many will be responded to in less than 15 minutes. So let's have a look here. Draw this thing, see if we can make any sense out of it. So 25 minutes is your mean, okay? And we're looking for how many will be responded to in less than 15 minutes. So this is where we're at. So just look at this. Interesting. What percentage are we looking for here? Take a guess. So now we just plug in your Z value. 15 minutes minus the mean, all divided by the standard deviation, gives us a number of negative 2.22. So 2.22 is right here, which is 4868. My blind eyes can see that. Okay, but you have a look here. I want to know everything to the left of this, because that's what the question is asking. Okay, so I'm only looking for this amount. But wait a second. So there's the same one, okay? I'm looking for this amount. How do I find this amount? You see, we found this number here, the z value, which was negative 2.2, which would be right here. And we found the probability, and that's from here unto here. But that's not what we're looking for. We're looking for the other side. So how do you solve for this? We know that this whole side is 0.5, and if from here to here is 0.4868, we subtract this from this, and now we get a probability of 1.32%. Okay, that's how this one goes. So be careful with these. You may have to, because remember that slide that measures from the mean out, that's what it's measuring. So if I get a z value here of 2.22, that's right here, it's only measuring from here. But if I don't want this, if I want from here, you've got to subtract 50% from 48%, and you'll get 0.0132, which corresponds to 1.32%. Now, the final. If 80 calls are randomly selected, you take your 1.32%, multiply it by 80 calls, and you end up getting 1.056 calls. So hence, approximately 1 call will be responded to in under 15 minutes. So here's this is the application that I'm looking for. It's I'm sure it's not real life, but this represents or replicates real life, and this is what we're looking for right here. And I hope you guys are doing all right. Please take some time, try these out. Once it clicks, it's cake. I just want all of you to get to that point, and the only way to get there is to try them. Okay? And make lots of mistakes. Go for it. Now's the time. Make mistakes. If a question's bothering you, let's set up a WebEx. Shoot me an email saying, Ian, question 3B, I've tried it twice and I can't get the right answer. Can you help me out? Don't ever try a question more than twice. If you're not getting the right answer after 2 times, shoot me an email. Don't waste your time, waste mine. Okay? And but try these out. These are good. This is what I'm looking for. What do we got as far as questions go? Because stick around, we'll go over the assignment. And yeah, talk to me. Any questions? Anybody still there? All right. Let's go over the assignment. And if I can find it. Yeah, right here. So this is where we're at as far as the original assignment. I gave it to you as a paper copy, so that you guys could work on these things, okay? I'm just going to screen share right now. And so, but this is how it'll look like on Blackboard on the e-portal, okay? And I'm trying to save trees, and I apologize there for the last minute change, but I just thought that you guys could try something a little different. And if I save 10 pieces of paper, then my job is done. And if there's any issues with this, let me know. I don't want to put you guys out, okay? Please remember the parameters there for a deck of cards. There are 52 cards. There are 4 suits: hearts, diamonds, clubs, and spades, okay? There are 13 of each, and know the cards that are in there, 2 all the way up to ace. Okay, there are 3 face cards per suit. So this is what we're looking for there. What is the probability of drawing a spade? And I've given you guys these parameters right here. Answer is a percentage. Okay, what is the probability of drawing a red even numbered card? Well, you're going to have to go through even numbered cards. So I'm looking at 2, 4, 6, 8, 10. Red, There are two, there's diamonds and hearts. So from there, you can figure out your probability. Okay. What is the probability of drawing a king or an ace? Remember those key words? Or, and then, and then. Suppose you select without looking 2 marbles from a bag containing 4 red marbles and 10 green marbles. So what's your total? 14, right? These kinds of things. Find your probabilities. Answer as a lowest fractional form. Okay. Again, same banana there. What are the odds? Be careful of odds. Odds is different. Okay. Where probability is the number of desired divided by the total. Odds are the number of desired divided by the number of undesired. Okay, it's different. Okay, and I've given this to you here in fractional form, 5 over 12. This is your probability, and from this probability, you should be able to tell me the odds. Okay, of an event happening there. Same banana here. You'll notice there they're in ratio form. Please choose the correct one. Any issues with converting fractions, ratio, decimals, these kinds of things, shoot me an email. Okay, this one's a good one. What are the odds of drawing a number 10 card from a deck of 52 and then rolling a 4 with a 6-sided dice and then getting ahead on a flip of a coin? So you got and then, and then, and then. What's going on there? And you're using odds. Okay? And then with odds. All right? A person owns a collection of 99 DVDs, of which 52 are action movies. If one DVD is chosen at random and then another without replacement, find the probability that both are action movies. Okay? So you remember with replacement, without replacement. At a used book sale, 90 books are math books. This one here, it'll sound strange, but welcome to statistics. At a used book sale, 90 books are math books and 130 are science books. So, math books, 90. Science books, 130. You need to fill in these. You can't do this unless you fill this in. That's why I gave it to you. Of the math books, 35 are statistic, while 60 of the science books are geology oriented. Okay, ugly, but fill in these and then you can extract your probabilities and whatever I'm asking you for. Okay, so there's A, B, C, and D. After you get into question 9, you'll need the Z table, which is attached there at the back. Okay, but it's also in the PowerPoints as well in the folders. Okay, and here you're doing exactly what we covered there today. You want to find the probability to the right of Z is equal to 0.23. Okay, so it's so similar to the right of 0.23. So your 0.23 value would be right in here. So you would be looking for everything over this way. So how do you do it? It's exactly the same way as what we just did right here. Okay, I've given you the Z value. You just go to your table, find your probability. This one here to the left of negative 1.43 standard deviation. So draw it. There's your mean. Negative 1.43 would be here, so you're looking for everything to the left of it. Be careful with that one. It's kind of like this one here. Where did it go? The one where you had to subtract. Yeah. Okay. It was just like that one there where you had to subtract. Okay. So that's where we're looking at there. These are all just different mix and matches, kind of the same question, doing it over again. And here are some application questions like we did there the last couple slides, okay, where I've given you the mean, I've given you the standard deviation, okay. Here's your value that I'm giving you. So find the probability the student makes more than 15,000. Well, draw your curve. There's your mean, your standard deviation. Get an estimate of what your answer should look like. Okay? And same thing here. Student makes between 13,000 and 14,000. And again, just more questions there. So that's what we're looking at there. I hope it's not too taxing. Nail this, because your quiz 3 is going to be exactly the same banana. Your test 3 will be exactly the same banana there. Choose your correct answer, upload them there into Blackboard. But that's where we're at. And how are we doing? Okay, sorry, Megan, I missed you. But how you doing there, Elena, Jade, Jesse, Megan? I'm going to stop recording now, and y'all can shoot me some questions.